Quadratic formula, and today we're going to look at decimal solutions. So instead of having your solutions to a quadratic equation written as a radical, sometimes you'll be asked to have your answer in decimal form. If your radicand is not a perfect square, we want to use your calculator to convert it to a decimal form and then complete the problem. So what does that look like? So let's say for an example, we solved the quadratic formula and we got to the point of -5 plus or minus the square root of 10 over 3. Well, 10 is not a perfect square. There are no perfect square factors we can pull out of the radicand to simplify. Either way, we still want to go ahead and change this to decimal form. So I could put in my calculator the square root of 10 and get 3.16. Now we're still going to get two answers, much like we did when we solved by factoring. We're going to do -5 plus 3.16 divided by 3. And we're going to do -5 minus 3.16 divided by 3. So your calculator can do a lot of this work for you. -5 plus 3.16 divided by 3 gives me -0.61. And -5 minus 3.16 divided by 3 gives me -2.72. All right, let's look at this one. Let's say we solved the quadratic formula. We got down to this point where we have the square root of 113, and 113 doesn't have any perfect square factors, so reducing is not going to really do too much. So we want to go ahead and turn this square root of 113 into decimal form. Put that in your calculator, and you'll get 10.63. And our two solutions are going to come from -7 plus 10.63. and -7 minus 10.63, and both of those are divided by 16. So I put in my calculator -7 plus 10.63 divided by 16, and I get 0.23, and -7 minus 10.63 divided by 16, and get -1.1, 1 and 1/10. So we still got our two solutions. Now, this is still a correct answer in radical form. It's just many of the times with quadratics, they'll ask you in different forms, and you'll need to know both. It's kind of like knowing that 1/2 and 0.5 are the same number. We have to know that this would be a solution in radical form to the quadratic equation, and this would be the decimal forms. So we still need to know that 1/2 and 0.5 are the same. We still have to know that both of these forms are acceptable solutions or equivalent solutions. All right, you guys go ahead, try this one on your own, convert that radical to a decimal, find your two different solutions, and then restart the video from here. All right, welcome back. So if we turn the square root of 14 into a decimal, we should have got 3.74. Then our two problems are going to come from -2 plus 3.74 and -2 minus 3.74, both divided by 2. And like I said, your calculator can do a lot of this work for you. We do -2 plus 3.74 divided by 2, and we get 0.87. And -2 minus 3.74, we get -2 and 87/100ths. Two decimal forms for our solution. All right, so let's try this one from the start. You guys go ahead and solve using the quadratic formula. And then I want you to select, or you write down, which of these different solutions are true. Select all true solutions. So use the quadratic formula to solve and come back and see how you did. All right, so if we're using the quadratic formula, we need to identify our A value, our B value, and our C value. In this case, we have A of 1, a B of 1, and a C of -5. We're going to substitute those into the quadratic formula. And when you do your first substitution, do not try to do any operations. Try to get in one clean substitution before we start simplifying. Then we can go ahead and simplify. 1 squared is 1. -4 times 1 is -4. Times -5 is +20. 2 times 1 is 2. Then in the radicand, we have 1 plus 20 is the square root of 21. So I have -5 plus or minus the square root of 21 over 2. And 21 is not a perfect square, so we're going to go ahead and change that to our decimal answer. Take the square root of 21 and get 4.58, 4 and 58/100ths. And so we do -1 plus 4.58 divided by 2, and negative 1 minus 4.58 divided by 2, and we get our two decimal solutions of 1 and 79 hundredths and negative 2 and 79 hundredths. So which of these are correct answers? Well, we need to know all the ones that are equivalent, which sometimes we can kind of see those in our work as we went. So we had negative 1 plus or minus the square root of 21 over 2, which is back here. And we have negative, we have 1.79 and negative 2.79. And I could go back and double check. This one doesn't look like anything we had along our way. It's not equivalent. It's not like they pulled out a perfect square factor and reduced anything. That just looks similar to this, but the wrong number. And negative 1.79, well, I have my two decimal answers, and I got a positive 1.79. And I could go back and double check my math and make sure I didn't miss any of my signs. And those look like good answers. So multi-select answers are very common with quadratic formula because your answer could be in so many different forms. Hope that, guys, helps you guys out getting everything to decimals from the quadratic formula and remembering that we could still have radical form answers as well. Have a great day. OU2 spells out.